Now that I'm all here, I would like to introduce myself. As of course, I'm Rowan, and as many of you know, I'm a biomedical engineer. And here's a picture of a 3D printer that doesn't belong to the University of Oxford, but it's sitting in my research room out at the Botner. It was bought by a couple of my colleagues who pulled their money together and decided to buy it. It is a hobbyist build-it-yourself 3D printer, and what you are able to do is design pretty much any shape you want, even if it can't be traditionally manufactured, on a computer, and then export it and send it to this printer and print it out. You can print literally any shape. So now, of course, I asked my friends if I could print something, and you don't have to necessarily design it yourself. I found 25 websites that have thousands of designs that are already existing and which you can download for free and send to your own 3D printer. So it's massively open source. You can literally print anything, design it yourself or not. And so what I decided to print when I could do absolutely anything? A keychain. Whoa. But in my defense, it's a pretty cool keychain and it can move. And now instead of working, I just sit there all day playing with my keychain. But I want to talk about what I was doing before I came to Oxford. I was at the University of Cape Town and I was doing a master's project in prostheses. So if you have your arm over here, this is your humerus bone, this is your radius, that's your ulna. The head of the radius bone, which joins the elbow over there, is one of the most broken parts of the body because when you fall like that, that's the one that impacts. It's also very small, and which makes it fracture very easily, and especially in old people with weak bones, often what they do is just replace it with a prosthesis. So what we did was we scanned a cadaver, and so that is a 3D image that we put onto a computer of a healthy radial bone. This is one from a trauma patient in a hospital, so that's what it's not meant to look like. And you were able to 3D print a whole bunch of those broken ones in order to play with them. And so now these are pictures of my master's project from the University of Cape Town. Different iterations are made of trying to improve radial head prostheses. I would like to emphasize how small this is. It is literally that big, very difficult to translate from a computer to real life, which is why so many iterations are important. Coming to the University of Oxford, I've got a friend in my same research group who is building vessels in order to grow biological material, and the shape and dimensions he needs are very specific. The only way to do it effectively is to rapidly prototype a whole bunch of different options and find the one that works the best. I also want to talk about the Radcliffe Science Library, which many of you know in the science area up on Park Roads. They have 2 3D printers, which anyone in the University of Oxford can use. And recently, people have been using it for things such as building models of bronchi to help with developing bronchoscopes, making mounds for cameras for scientific experiments, models of bird bones, teaching materials, different types of textiles. And a student called Ed Choi, in an article released last week, what he has done, he's downloaded an open source design for a prosthetic hand. He's printed out 2, and he sent them to an amputee camp in Sierra Leone, where he's given them to amputee patients. It's a design that's made by a company called Enabling the Future. And here's a young amputee in Colombia who's actually got one, which is an Iron Man one, and it's so cool because the hand actually lights up like Iron Man, which is fantastic. The Radcliffe Science Library also has 2 3D scanners, which is exactly what it sounds like. You hold a device and it creates a 3D model of the thing that you're playing with. I have used these before. It's very difficult to use, so I won't go into it. I'm not an expert on the scanners. Printers are cool though. Now, outside of Oxford, what's happening? Well, in London, teams of orthopedic surgeons have decided that people with complex bone fractures, it's too difficult to use CT scans to find exactly where to place the prosthetic bones. So what they're doing is a patient that comes in with a trauma, they'll immediately print the fracture site and either then practice where they're going to place the implants or 3D print a metallic implant that can be tailor-made to that specific patient. They can also make a scaffold, a metal scaffold like you'll see over here, which is, if there's a very complex and large fracture, they can just cover the entire area, completely anatomically correct, and it's just a structure that holds it together. So it's replacing bone, in other words. Now, Replacing bone's fine, it's just, you just want something that's strong. How do you replace something like cartilage, which is more than just, it's got to be flexible, it's a little more complex than just bone. And very recently, in the past couple of weeks, past couple of months, they've come up with ways to print noses and ears. That's, again, just dead material that is able to be implanted in that area. And now that they have bone and cartilage, they can print entire knees. And there are currently 80 people walking around the earth with 3D printed knees, which I think is very cool. And also, breaking news, more breaking than probably anything else in my presentation, is they are now able to 3D print living material. What they do is they print the scaffold. Okay, so they can't print living material, they can print the scaffolds. But then on the scaffold, they can grow the living material. And now, more than bone, more than cartilage, you have something that you can implant and can actually become like a human ear that can grow normally. Even more exciting is the fact that they got a goo that when it grows, it tends to grow into the same folds as a human brain. So this potentially is the first step to growing a human brain, which is pretty cool. Now, there were at some stage worries about the safety with regards to 3D printing technology, but I did some research, I won't go into it, but the rays that people thought it was sending out and the issues with biocompatibility, they've all been solved. So commercial things like this are available in many research departments in medical companies. Thank you very much.